Hello guys, welcome to Infonity. This is your host Mark. So today's our topic is about Neuralink. Without any further delay, let's get started. Neuralink is a neurotechnology company founded in 2016 by Elon Musk and others with the goal of developing implantable brain-machine interfaces, BMIs. The company's mission is to help people suffering from neurological conditions and injuries, as well as to enhance human capabilities by allowing people to control technology directly with their thoughts. BMIs are devices that allow the brain to communicate directly with external technology, such as computers or prosthetic limbs. By decoding brain activity and translating it into digital signals, BMIs have the potential to allow people to control technology with their thoughts and even to restore lost functions, such as the ability to move or speak. Neuralink is developing a variety of technologies to achieve these goals, including implantable devices that can record brain activity and wirelessly transmit the data to external devices. The company is also researching ways to stimulate specific areas of the brain to restore lost functions or to enhance existing abilities. The potential benefits of BMIs are vast, with applications ranging from treating neurological conditions and injuries to enhancing human performance and enabling telepathic communication. However, the technology also raises a number of ethical considerations, such as issues of privacy and autonomy, as well as the potential for misuse or abuse. As Neuralink and other companies in the field continue to push the boundaries of what is possible with brain-machine interfaces, it will be important to consider the potential consequences and implications of this exciting and rapidly advancing technology. Neuralink's brain-machine interfaces, BMIs, are designed to allow the brain to communicate directly with external technology, such as computers or prosthetic limbs. This is achieved through the use of implantable devices that are surgically placed in the brain and connected to electrodes that can record the brain's electrical activity. The hardware components of Neuralink's BMIs include the implantable device itself, which is designed to be as small and unobtrusive as possible. The device is equipped with a number of electrodes that are used to record brain activity and transmit the data to external devices. The device is also equipped with a wireless transmitter that allows it to communicate with external devices without the need for wires or cables. In addition to the hardware components, Neuralink's BMIs also rely on sophisticated software algorithms to decode the brain's activity and translate it into digital signals that can be understood and interpreted by external devices. These algorithms are able to analyze the data collected by the electrodes and extract meaningful information, such as the intention to move a limb or speak a word. To implant the devices in the brain, Neuralink uses a combination of traditional surgical techniques and advanced robotics. The surgical procedures are typically performed by a team of neurosurgeons and are designed to minimize the invasiveness of the procedure and reduce the risk of complications. Overall, Neuralink's BMIs are designed to allow people to communicate with technology directly with their thoughts, enabling them to restore lost functions or enhance existing abilities. The technology has the potential to revolutionize the way we interact with the world around us and has numerous applications in a variety of fields. There are a wide range of potential applications for Neuralink's brain-machine interfaces, BMIs, which allow the brain to communicate directly with external technology. Some of the key areas where BMIs could have a significant impact include treating neurological conditions and injuries. BMIs have the potential to help people with neurological conditions, such as paralysis or stroke, by allowing them to regain lost functions or control over their limbs. For example, a person with paralysis could use a BMI to control a prosthetic limb or to communicate with others through a computer. Enhancing human performance, BMIs could also be used to enhance human abilities and performance, such as by allowing people to process information more quickly or to communicate more efficiently. For example, a person could use a BMI to access and analyze large amounts of data more quickly or to control multiple devices at once. Enabling telepathic communication, BMIs could potentially allow for telepathic communication, or the ability to transmit thoughts and ideas directly from one person's brain to another. This could have a wide range of applications, including in education, business, and even personal relationships. Other applications, in addition to these main areas, BMIs could also have a number of other applications, such as in the fields of defense, entertainment, and transportation. For example, BMIs could be used to control drones or other military assets, to create immersive virtual reality experiences, or to enable self-driving vehicles. Overall, the potential benefits of BMIs are vast and varied, and as the technology continues to advance, it is likely that new and exciting applications will emerge. As with any new technology, the development and use of brain-machine interfaces, BMIs, raises a number of ethical considerations. Some of the key ethical issues to consider include privacy. One concern with BMIs is the potential for the devices to be used to invade an individual's privacy. For example, if a BMI is able to decode an individual's thoughts and transmit them to external devices, there is a risk that this information could be accessed or used without the individual's consent. Autonomy. BMIs could also potentially be used to manipulate or control an individual's thoughts and actions, raising concerns about autonomy and the potential for abuse. It is important to ensure that individuals have the right to make their own decisions and are not being unduly influenced by external forces. Misuse or abuse. As with any technology, there is a risk that BMIs could be misused or abused. For example, BMIs could potentially be used to exploit vulnerabilities in an individual's brain or to manipulate their behavior. It is important to put safeguards in place to prevent these kinds of abuses from occurring. Equity and access. Another ethical consideration is the potential for BMIs to create inequalities in terms of access and affordability. It is important to ensure that the benefits of BMIs are available to all, rather than being limited to a select few. Overall, it is important to carefully consider the ethical implications of BMIs and to take steps to mitigate any potential negative consequences. This may include putting safeguards in place to protect privacy and autonomy, as well as ensuring that the technology is used in an ethical and responsible manner. As a rapidly advancing field, the future of brain-machine interfaces, BMIs, is difficult to predict. However, there are a number of directions that the technology could potentially take in the coming years. Some potential developments include greater precision and accuracy. As BMIs continue to evolve, it is likely that they will become more precise and accurate in their ability to decode brain activity and translate it into digital signals. This could allow for more sophisticated and nuanced control over external devices and systems. Wider range of applications. As the technology improves and becomes more widely available, it is possible that BMIs will be used for an ever-growing range of applications. This could include everything from treating neurological conditions and injuries, to enhancing human performance, to enabling telepathic communication. Miniaturization and wireless capabilities. One direction that BMIs could take is towards greater miniaturization and wireless capabilities. This could allow the devices to be more easily implanted and to function more seamlessly with external devices, without the need for wires or cables. Increased accessibility and affordability. As the technology matures and becomes more widespread, it is possible that BMIs will become more accessible and affordable to a wider range of people. This could help to ensure that the benefits of the technology are available to all, rather than being limited to a select few. Ethical considerations. As BMIs continue to develop and gain wider adoption, it will be important to carefully consider the ethical implications of the technology and to take steps to mitigate any potential negative consequences. This may include putting safeguards in place to protect privacy and autonomy, as well as ensuring that the technology is used in an ethical and responsible manner. Overall, the future of BMIs is exciting and full of possibilities. As the technology continues to advance, it will be important to carefully consider the potential consequences and implications of this exciting and rapidly evolving field.